Okay, good. Yeah, my name is Keith Flynn. I'm with RT Tech Software. We're a Canadian-based company with established operations in different parts of the world. We've been operating under RT Tech since 2011. Prior to that, my background from a parent company called ADM Systems Engineering, where we did a lot of feet on the ground data management projects, which pushed us into the data analytics and into the industrial app side. So my background is electrical engineering with computer science. So when I started, I was in the plant, so I was the end customer, and then migrated out into consulting and now into the software industry. So been at it since about 1991, doing large data historian type projects and data-driven projects right from the very beginning. So.
Is this working? Hello, my name is Lior Frenkel. I'm the co-founder and CEO of Waterfall Security. We are a vendor of unidirectional security gateways, which are hardware security-based devices that enable safe and secure integration between OT and IT integration environments. Where the main thing that we provide is protection of the side, and the OT side to share real-time information with external environment, the internet, cloud services. Something's wrong with this. Yeah. And while protecting the OT side from attacks or penetration from the internet, from external locations and so on.
Okay, thank you. So I certainly have some questions in mind, but I'd love to hear yours too. Anybody want to start with the first question? Yes, sir, right in the front.
Okay, so Bill, yes, I saw your presentation previously, an excellent, very specific but very valuable application there. One of the things that we've been investigating with the big data and that, or some of these analytic tools and that there, obviously you have one that works very quickly within your, you mentioned that some custom there, but can you tell us a little bit about the analytics, like technology in terms of some generic? Is it something simplistic? Is it something pretty complicated? What is the main driver of your analytics? Obviously you have a lot of sensors that give you that good information, but is it basically that you've got this type of technology? Is it like a what?
Essentially what we're doing is we've highly characterized the base oil that's coursing through the engines. So for instance, viscosity. We all know what viscosity is. It's if you were to take cooking oil and put it in a saucepan to maybe prepare some garlic or something. You heat that up and that oil is going to get very thin. It's going to get as thin as water. Put it back in the refrigerator and it's going to get fairly thick and congealed. So in the case of these large engines where the operating temperature might span about a 12, 15 degree temperature range, viscosity is going to go up and down based on the temperature. Well, guess what? There is no straight line between the temperature, the viscosity measurement across that 15 degrees. You might assume there is. In fact, mechanics typically do, and even in the labs will have a viscosity rating per some ASTM protocol tests, viscosity at 40 degrees C and 100 degrees C. What we've done instead is actually characterize that oil, define that curve based on 5 to 10,000 data points, turn it into a formula, put that formula embedded into the indoor software, and actually say, okay, at temperature X, what is the viscosity supposed to be? And then compare that against the range, the actual threshold from an SAE grade. So that's a very simple example of how we're doing some analytics on just viscosity. Now you compare that with 41 other attributes, and there is a gold mine of data that you can mine.
Okay, so it really came up to some characterization, some modeling, some statistical analysis for each of these key parameters that you needed to figure out, and then you incorporated some type of model into that analytics, that some combination of all parameters will give you certain answers that you need to follow.
Yes, and additionally, this gets into some IP that's been very well protected, but we also have a self-learning or an AI element in here where we're constantly learning what the engine condition is matched up with the performance parameters of the compressor, as well as fuel conditions and environmental conditions. So we can actually then learn what these behaviors are, then apply those learned behaviors into future algorithms.
If I can add something on this, although we come from this security or the enabling part of this technology, but we are involved with many vendors that want to have cloud analytics, and we are involved with many cloud providers. And I think that one of the most impressive things that Logiloop does is the combination between edge processing and cloud analytics. Relying only on cloud analytics for things like this isn't good enough, because just gathering data and sending it to the cloud, you can't really rely on it for real-time actionable information, because in many places communication isn't reliable. You can't trust that it will work 24/7 all the time, in offshore platforms and satellite links, and you still want local closed loop feedback. So this combination is unique, and I think it adds a multiple of value to the customer.
Thanks. Keith, can I just ask you to comment to that as well, your approach on analytics?
Yeah, on the analytics. On the analytics side, one big misconception we've encountered is that when you walk into, let's say, a fresh site, you're new on a manufacturing, and they're asking you to do calculations. It's hard to engage the in-stream, the real time, without the history. So coming into cloud solutions or even on-prem solutions, when you go to derive the analytical, whatever the model is or the formula that you're going to engage in-stream, you need the history to do that. So a big thing that we've encountered is you have to set the expectation for a lot of these in-stream and real-time analytics, and set success criteria at the beginning, where you start to say, in 3 months we can deliver this and we can refine. He mentioned earlier that it's continuously refining. You need some history to start. So getting into the in-stream, you actually need the historical there sometimes to build on that. So.
Okay, good, thank you. Next question, please. Sorry.
So, it should be on. Okay, all right. Can you speak to what protocols you're using to communicate machine to machine or to the cloud, and how that quality of service, what your thresholds or experience is with that?
I'll take it from a software side. We're currently transmitting using the AMQPS. We're based on Azure with our solution, so I can't speak on the other behalf.
We're actually using Modbus RS-45 protocols to pull the data out and send it up. Pardon? Actually, we have an aggregator, so we collect all the information in an aggregator. Then we've got different protocols depending on each client.
Hi, Bill. The part that you talked about when you do the quality test, and quickly analyze the results, does that get sent, does that event triggers for additional transactions, maybe in the ERP system or anything like that? So the LIMS to ERP kind of interface, is that anything like that in your solution?
Our clients are very interested in tying together the data, our analyzed data, into their ERP systems. And as we move closer to business process information, there are a multitude of opportunities for integration into their ERP. So as we mature this out with individual clients, I look forward to their embracing this information throughout their business ERP.
Hey, Bill. I liked your presentation a lot. I thought it was good. My question was kind of related, though, and it was specifically that picture that you had up on the wall of the control room, and it was, every screen was gray, and then there was your sort of black user interface, kind of very prominent. But it occurred to me that as new devices like yours start to materialize for different purposes, and they're all sort of presenting new, novel information and insights, that the room could look very different in the not too distant future, and it might be very complicated to kind of have everybody have their own user interface, whereas prior they had sort of a standard interface they were using, and then trying to discern based on that standard interface what was happening. Are you finding any pushback for you to inject your user interface into, what is otherwise established?
Very, very insightful question. And depending on who you talk to within the client, in that particular image, you saw basically a Wonderware environment, and with the exception of our screen. And we spent quite a bit of time modeling a UX experience that provides a very intuitive, instantaneous understanding of thresholds, real-time, histogram, etc. That would have been lost if it was translated into a common Wonderware environment. So the operators were massively behind having that differentiation so they could instantly see what's going on at a they don't even need to look at the numbers. They can look at the pointer at a threshold and know. Integrators, basically the Wonderware integrators in this client, were actually trying to force us into, we'll just recreate that in Wonderware. And of course, it's going to be watered down. You're going to lose that. Part of the capability to actually exhibit that nice UX interface comes from the ability from Waterfall to actually replicate in a very safe manner, so we don't have a direct internet connection, but to replicate that screen so that it's safe, it's secure, but yet we don't compromise the UX experience. So from a business management point of view, the operators and the directors of the IOCs, they're all over having a nice standout UX that can be easily comprehended. To the IT side, not so.
Keith, I see you nodding your head there. Do you want to talk to that too?
We've gone through the same process. It's about, do you please the many or do you please, one? Because you get into color sets, layouts, graphical designs, which gauges. Again, coming from the automation world where we did the Wonderware screens, you vary from operator to operator, not just from plant to plant or company to company. There are preferences. Moving into our latest technology, what we've done is we've delivered a standard set of build screens. You build them yourself and you could publish templates. We still go with the mobile apps for push notifications. So we try to capture, the essence of the end user experience through actual, native apps. But then we just decided to open the door with a RESTful API. So for those who are not complacent with what we've delivered, we try to work with the integrators or work with the control system so that we can make it available. So we try to cover all grounds, and I'm sure we're still not going to make everybody happy, but it is one of the biggest challenges. You could have the best software in the world with the most accurate analytics, and if the gauge is not the right color or the right shape, sometimes it gets dismissed. So.
All right, thank you. Next question. Sure.
I'll just speak up. So one of the things that you obviously open up when you push data into the cloud is even if it is secure, it can become more accessible to many other people, not in terms of secure, insecure. But the previous panel was a gentleman from Falconry and someone else talking about doing advanced analytics and things like that. I'm curious about your thoughts on, do you see yourselves maintaining your expertise and your domain expertise and your IP on the local processing, pushing it up to the cloud, but then partnering in terms of a marketplace with other vendors who come in with different sets of analytics? Maybe one supplier likes one company, one supplier likes another, but they like your product. Or is that something that you think you would develop yourself or partner with and go to market as a combined solution?
Actually, I think the right answer to that and the right strategy is what's best for the client. And so if it's speed to market, if it's providing the most value for the bang for the buck in processing and information, we'd be silly not to entertain partnering with outside third parties to maybe layer their analytics on top of ours and so on.
I think we can take an example from other markets. You know, once you have data available, like big data from many sources, and in this specific sector, once you have a technology that provides you a way to send it out safely, if it's out there, it will be used in multiple ways. You know, like when you go to retail, so they started gathering information on customers, and now they are selling advertisement based on, you know, which type of Coke you drink. So once that data is out and maybe anonymized, maybe you know, made more you know, remove you know, like commercial information, so that data will be used again and again in more interesting ways and in more complex ways than just what we currently planned. So I think over time, the data that they are moving out and processing will be then reprocessed and provide a lot of insight that today we don't even know, you know, what we need to ask.
So like overhaul service providers bidding on a job to overhaul, you know, 500 compressors, and they get the anonymized data and they bid on that job, then they find out, oh, this is for some particular provider. But yeah, that's an interesting idea.
I wouldn't mind adding to that. For some, you know, considering ourselves an IoT solution provider, we focus very much on point solutions. So when it comes to a customer and what we aim to deliver, to stay focused and to deliver with, you know, a concise set of objectives, we stick sort of within our bounds. You know, the energy management, the maintenance and reliability, and then the workflows. But that doesn't mean that we want to limit. So this whole concept of opening an API means we can do value add solutions and partner so that our cloud can talk to your cloud sort of deal and share information, obviously, with, you know, customer approval. But it's a big task to take on to go to market, just being a cloud data provider. You're giving yourself, you know, an open book in terms of what the customer can expect, or even in terms of a deliverable. So.
One question there, please.
Yeah, so when I look at your application, my question is, who owns the data you're providing? Because you have the compressor manufacturer, that's the source of the data, so to speak. You have your instrument that's doing the measurement, and then you have the owner of the asset who needs that could benefit from the data. So tell me about, in your mind, how you resolved who owns the data. Who has liability for that data?
Excellent question. The client who's contracted with us to provide a long-term data analytics solution actually owns the data that's been processed for their asset. They own the compressor, they own the engine. Now, historically, this might come as a surprise, but if you were to lay out $1 million for an engine, $1 million for a compressor, $1 million for installation, you got $3 million invested, and with company A, company B, and then subcontractors to put it all together and commission it. It's surprising, but the actual data from the engine control module for that manufacturer, OEM manufacturer's engine, is not accessible by the client. It's actually behind a walled garden. And it's just like if you took your American or German or Japanese car to get some service done, and they put the dongle underneath the dashboard to find out what is that error code. What does E086 mean? Is there any history with that? Well, You might never know. The service tech might never know. But eventually, BMW or one of the other manufacturers is going to know what that is. Same deal in our case. We actually sit outside the walled garden, so we could provide that histogram of data to the operator, to the owner of that hardware. So they invariably, they want to know what that data is. Now at the atomic level, our database, our data warehouse will actually have the anonymized data, so that if we looked at every Caterpillar engine or every Ariel or every OEM manufacturer, we look at the fleet, now we have a giant big data aspect of what's the behavior and what's the failure rate given these various conditions throughout the entire fleet. So it's a split between process data is owned by the client, and raw atomic anonymized data becomes large loop property.
Other views on that, Leo, Keith? No? Yes?
No, we've been challenged with, asset health monitoring by vendors, and in a lot of cases you see the split signal. So, it's really about making the data accessible for better service, but it's one of those things that I think would be challenged on each level. If you're getting split signal data, who stores it, or depending on what its purpose is. So.
Right.
Yeah, so do you ever get concerned that if your analytics of that data that you own, right, is detrimental to another party in the game, that other party, that you have some liability in that or in that prediction or in that conclusion that your analytics have made? You kind of understand the question? Do you have a concern that you're going to be liable if you say this is this and it really is that?
Well, we'll provide the data and analyze the data and provide results. Now, where we have to actually be careful and draw the line from a reliability point of view is recommendations. And so we've been instructed not to, by our board, not to make recommendations. Provide the data. Yes, the algorithms to actually analyze that data would be discussed with the client. We set thresholds. We understand the definition of dangerous conditions with the client. They sign off on that during commissioning. And so that the results that we show them and share with them on a real-time basis is basically it's information. And we actually have to very carefully draw that line from a recommendation.
Okay, if nobody else has a question, I have. Yes, sir.
I have a general question. Maybe you can even answer this. In your session here, you had discussed the unique challenges posed by IoT data. From your background in that, what have you seen as some of those unique challenges?
Keith, you want to start?
The quality, just being. I'll pick our energy management app for instance. It's all about automated reporting. We're talking about meters. He mentioned earlier, network drops. It's that consistent, the ability to provide a consistent stream of data within certain operating parameters. So making sure the data that's coming in, you don't end up with some outliers or just removing the bad data. So we've put a lot of time and effort into making sure we have clean data. So we talk about in-stream analytics. Analyzing the data based on its own quality within a set of guidelines and parameters is one of the first stages before it even hits anything proprietary.
I'd like to add on top of that, we also are concerned about quality of data, continuity of data, nulls, duplication of data. And so we've had to write quite a few different routines to actually look for and throw out that noise in the background. And we are, that's a constant challenge for us, is to look for patterns that are not normal patterns, but are actually related to data quality issues. And then continue to write these little routines and embed those into our algorithms such that we don't make decisions based on, oops, we got this lack of data has affected an average or a trend. And so we actually have to identify those chunks and throw them out, and then and actually take those into consideration.
One thing to add to that, we don't own, in most cases, in our situation, we don't own the sensors. So the calibration, is it up to us to report on data that's, not calibrated? So that's also a challenge that we face. We start to identify things, but slow drift or slow at a calibration. So it's really on the end user and on the customer.
If I can add from a different perspective, my background is more on security, and one thing that happens from time to time when you get too wide perspective is, and that's something that is, I think, is something that you always need to take into account when doing big data, is sometimes too much data isn't good. Sometimes you get fake correlations, or not fake, but like shadow correlations that looks really interesting, but have nothing to do with reality. Even if everything is right and all the data is clean and your algorithms are perfect, viewing things from so high above and throwing in so much data sometimes results in ends up with results which are not right, are not true. So it's a different answer to your question, but I think it's important.
What I'd like to also add is that in this orange box here, with some highly sensitive sensors, hydrocarbon sensors, other sensors, we recalibrate every 168 hours. We don't even have to touch the machine. That bottle of oil right there ends up in a FedEx truck, ends up in a lab within 24 hours, and then there are 50 tests on that oil that are monitored and managed via ASTM protocols. So the results of that oil analysis can then get fed back to this device, and we can recalibrate those sensors, because we'd much rather trust an ASTM protocol in a lab environment than in a robust environment, in a hot, vibrating, very hazardous environment. So to deal with the issue of potential drift or loss of calibration, we've got a closed-loop system where we're actually recalibrating the sensors.
All right, thank you. So that is the end of the session today. Thank you all for your time. So I think dinner is in the hotel today at 6 o'clock, and I'd just like to thank the panel one more time.